Okay, students, good morning. So last class we studied about solutions we have seen, no? Okay. Today we are going to see one lessons in organic chemistry. So the lesson is what? Haloalkane and haloarine. Okay. So basically, if you know the carbon valency, methane, ethane, ethene, alkene compounds, alkyne compounds, okay, some aromatic compounds. Okay, basically aromatic compounds means, first aromatic compound is what? Benzene. First aromatic compound. Okay, so the basic things, if you know, means you can easily to answer this. Okay, if any questions asking in this lesson, means you can able to answer. Okay, so haloalkane, haloarine. So we studied amine chapter, no, just like that. Okay, here also we have two topics. One is haloalkane, one is haloarine. Haloalkane means it is a aliphatic compounds. Haloalkane, no. Haloarine, arine means what? Benzene, no. Arine, other name is called, benzene. Aromatic compounds. Okay, so aliphatic compounds, aromatic compounds only we are going to study. Its preparation, properties and all we are going to study. Okay, understood? Okay. So most of the halogen compounds are used in medical field. Chloroform. Okay, you know that chloroform. Okay, it's chloroform is nothing but anesthetic. What is this? Iodoform. Okay, antiseptic. Understood? Carbon tetrachloride. It's a very good solvent. Then CFC. CFC means what? Chlorofluorocarbon. Okay. C. Or you can say CF2, Cl2, chlorofluorocarbon. Okay. So it's it's called a refrigerant. So most of the halogen compounds are useful in medical field. Okay. DDT, one compound is there. This also having chlorine. It's called halogenated compounds. All these compounds having halogens are there. Okay. The DDT nothing but it's a insecticide. Dichloro, diphenyl, trichloroethane. Okay. So this and all halogen compounds. It is used in some medical field. Okay. Right. So but our topic is only haloalkanes. Okay. So aliphatic compounds and aromatic compounds only we are going to study in this topic. Okay. Just copy them. If you want me, just copy them. Chloroform, iodoform, carbon tetrachloride, chlorofluorocarbon. This is called dichloro, diphenyl. So I'll give later this one. These are all applications of this lesson. Okay. Okay. So here, now the two topics we are going to study in this lesson. Here, one is called haloalkane. Okay. Here the formula is what? Both are having same formula. This also having formula is what? RX, or maybe any methyl, ethyl, like that you can substitute. X may be any halogens. Understood? Here also the formula is what? RX. So R may be what? Best example is methyl chloride. Ethyl chloride. This is a common name. Okay, we have IPS name is also there. So here CH3, CH2, CH2, Cl. Understood? Here haloarine means instead of R we can substitute what? Ring. Okay. C6 H5 Cl. So this is the first aromatic haloarine. Okay. Okay. What's the name? What is the name of this compound? Chloro, methane, chloro, okay. So the formula is RX. Understood? RX. So here instead of R I put methyl, ethyl like that. Methyl, ethyl, propyl, butyl like that. Okay. Instead of X may be any halogens. We can put bromine, iodine like that, anything. Okay. So here, how to give the name means IPS name. Just I'll give one or two name. What? Chloro what? This is a formula, ma. This is one haloalkane one compounds, haloarine one compounds. Both are having formula is what? Rx. Or maybe, that radical, any radical, methyl, ethyl, propyl, like that you studied. X may be any halogens, understood? So instead of R I put methyl group, instead of R I put ethyl group, instead of R I put propyl group, understood? So if you substitute means, we have some IPS name for that. What's IPS name means, you say in this direction. First you say this one, chloro, one carbon, no? So what? Chloro, methane. Are you following? Chloro, next one. Chloro, 2 carbon means what? Chloro, ethane. When you come to third carbon, we have 3 carbon, no? If you have 3 carbon means you give the number 1, 2, 3. So in this carbon only chlorine is attached, no? So it's the first carbon. So we can say what? 1 chloro. How many carbon? 1 chloropropane. Understood? It goes on like that. So suppose if I give like this, what is this? What's the name of the compound? So here you give the number from left to right or right to left. Which one is correct means? Left right. Because here lowest only we should consider, no? So this is 1, this is 2, this is 3, this is 4. 2 having chlorine, no? So what? 2 chloro butane. Understood? So this is all okay. Just copy them one by one. So first you put the heading haloalkane. Under haloalkane you copy them all this. Okay. This IPS name we studied in lower classes. We studied all the IPS name in 11th standard. Okay. But each and every chapter also they are giving. Whenever the lesson starts, beginning, they are giving IPS name. After that only we are going to study about preparation and properties. Okay. These are the example for haloalkane. No, this is the example for haloarine. Arine means benzene compounds. What's the name of the compound? Chlorobenzene. Okay, chlorobenzene is the IPS name. Or phenyl chloride is the common name, Okay, chlorobenzene. Understood? Okay, right. Can you have this? Okay. Next. Okay. See here, before study the preparations of haloalkane, we have some, some classifications present. Classification, you put the heading classification. Classification of, other name is called what? Haloalkane means called, IPSC name, no? Or we can say what? Alkyl halides. There are also, alkyl halide. Okay. Other name also you must know. Alkyl halide. Understood? Okay. So here they classify. First of all, I will teach the based on, just write, based on number of halogens. Based on number of halogens. Okay, based on number of halogens. If you have, the simple one, if you have one halogen means mono haloalkane. 2 halogen means what? Dihaloalkane, like that. It goes on. Okay. So here you just write in this way, mono haloalkane. Best example means I can give this one. Mono means what? Only one halogens, no, mono haloalkane. Okay. This is all, just you copy them. Dihaloalkane. Understood? it is only they classify into two types. One is called gem dihalides, okay, vicinal, okay, vicinal, VICINAL, vicinal dihalides. Or simply say, sometimes they will say only vicinal halides, okay, gem. Are you following? Two compounds having, we have two halogens, okay, but here gem means what? The two halogens are attached to the same carbon. Here the two halogens are attached to the adjacent carbon, that's the point, okay. You just copy them, this one here, right, under this, right, two halogens attached to the same carbon, two halogens attached to same carbon, understood? So examples, C, following, two halogens attached to same carbon, understood? Then you know that this is example. Can I give this, correct or not? Two halogens attached to the same carbon, no? Okay. Any one example you can give, but gem means two halogens attached to the same carbon. That's all. Okay. We can give propane. What is the name? What's the name of the compound? This is considered 1. This is considered 2. Okay. 1, 1 dichloro ethane. Can I say like that? Okay. Because this carbon only we have two carbon. We have two chlorine, no? So 1, 1 dichloro ethane. Correct or not? Okay. Same thing here. Here what is the explanation? What is the definition for this? Two halogens, adjacent carbon, nearby, okay, just right. Two halogens attached to adjacent carbon, that's all. Here, same. Here on chlorine, correct or not? Okay, it should be attached to adjacent carbon, okay. That's called vicinal dihalides, understood? Okay, then you can fill by hydrogen. You know the valency of carbon 4. Tell me. You know the valency of carbon 4. How to fill up hydrogen? H2. Correct or not? H2. Here also H2. Understood? Okay. 1, 2 dichloroethane. Are you following? 1, this is 1, this is 2, no? So 1, 2 dichloroethane. Are you following? Okay, right. Just right. Somewhere they will give one compounds. What kind of halide that is, they will ask. Understood? Gem dihalides only, mostly they are asking. Then you just write trihaloalkane. Understood? Here, trihaloalkane means compounds having 3 halogens. Understood? So you can fill by hydrogen. This is what? CH2 here, CH only here, CH2. Understood? Okay. Give the name. How to give the name? Here only CH will come. Don't CH2. Don't put CH2 here. 1, 2, 3. So what? 1, 2, 3. Trichloro what? Propane. Understood? Simple one. Right, fast. This one is important. The middle one is only important. Okay. Finished? Okay. This is based on number of halogens, one classification. Another one is, just write, based on hybridization. This only important. Hybridization, based on hybridization. Okay. Based on hybridization. What is hybridization? Overlap of orbitals to form new hybrid orbital. No, that's called hybridization. No, hybrid means new varieties. Okay, so whenever the two orbitals mix together to form new hybrid orbital, s orbital, p orbital mix together, we get sp orbital. One s orbital, two p orbital mixed together, we get sp2 hybrid orbital. Then sp3, it goes on. Okay, here again, based on sp3, we have three classification. Okay, based on sp2, we have two classification. Okay, so here sp3 means here first one is alkyl halide. Alkyl halide. Just put the heading. I'll give the definition to you. Are you following? Based on sp3, we have three classifications. Okay, three kinds will be there. Based on sp2, we have two kinds will be there. Okay, two types. Okay, simple one. See, first of all, sp3 means you just remember this one. We have 4 sigma bond around the carbon atom. Suppose here halogen is attached to this carbon. No, halogen is attached to this carbon. Okay. Around this we have 4 sigma bond should be there. Then only this carbon is called what? sp3 carbon. See, 1, 2, 3, 4. 4 sigma bond. If you have 4 sigma bonds, means it's called, this carbon is called what? sp3 carbon. Okay. Sometimes one Cl is attached to this carbon. Single bond means sigma bond. Okay. Here also single bond, no sigma bond. Here also understood. Here double bond comes means what? One is sigma bond, other will be what? Bi bond. So wherever which carbon chlorine is attached, around this carbon atom we have 3 sigma bond. No. If you have 3 sigma bond means that kind of carbon is called what? sp2 carbon. Are you following? Okay. This is called sp2 carbon. Here we have this carbon is called what? sp3 carbon. Understood? So based upon this only we are going to see. Okay. First you just note down this one. You split them. Okay. You make it into 2 column. sp3 I will give examples, then sp2 also I will give examples. Okay. They will give one structure. So which kind of halides that is they will ask. So first of all, you should know what kind of it is. It belongs to sp3 or it belongs to sp2. We have to find out. Then only we can decide. Okay. Simple one. First we will put the heading. Alkyl halides. So I will give one small definition. See, halogens attached to, right, halogens attached to sp3 carbon, halogens attached to sp3 carbon, which is attached to alkyl group, That's why it's called alkyl halides. Correct or not? Halogens attached to sp3 carbon, which is attached to alkyl group. Then it's called what? Alkyl halides. Are you following? Okay. See, simple one. You can give these examples. Suppose here, see, sp3 na, it looks like this. Okay. Suppose here halogens attached to sp3 carbon na, which is attached to what? Alkyl group. It may be methyl, ethyl, anything. Okay. sp3 means it looks like this. Okay. This is a skeleton. Okay. Then if you want means you can fill up by hydrogen. So how to fill up? CH3, CH2, Cl. This is example. No, same. Both are same. No. Okay. Suppose here, then suppose here, both the sides if you put hydrogen means primary alkyl halides. Suppose if it like this, suppose CH3, C, what is this? What is this? Here also what? See, I write it here. see, H. What kind of carbon? sp3. sp3 carbon, no doubt, no sp3 carbon, no. Here also sp3 carbon, but here just remember, then only it's called all are alkyl halides. But this is called primary alkyl halides, I am saying. This is what? Secondary. This is called what? Tertiary. Understood? Because this carbon only I am saying what? sp3 carbon, no. But this carbon is attached to only one carbon. That's why it's called, primary. This is sp3 carbon, no. Which is attached to how many carbon? Two carbon. That's why it's called secondary. This is sp3 carbon, no. Which is attached to how many carbon? Three carbon. That's why it's called tertiary. Understood? Just write all this. Be quick. 1 0 2 0 3 0. You put like that. You must know alkyl halides. At the same time, again on small category. Okay, what is primary or secondary or tertiary? Understood? Understood? Okay. Write fast. Next one. It is a be considered, allyl halide or allylic halide or allyl halide, no problem. Allyl halides. Okay. Write the definition, as usual definition. Halogens attached to, write fast. Halogens attached to sp3 carbon, which is attached to carbon-carbon double bond. Halogens attached to sp3 carbon, which is attached to carbon-carbon double bond. It looks like, so it looks like that. Halogen attached to sp3 carbon, no, because of 4 sigma bond, no, which is attached to carbon-carbon double bond. Okay, so this type of structure, if you see, means that's called what? Allyl halides. Understood? Now you can fill by hydrogen. After that, you can, suppose here CH2, cut or not? CH2, Cl. Understood? Then I replace here both the sides. I put what? HH, no. Then suppose if I put CH here, one side H, one side CH3. What? This called? Then simply remember, it's a very simple one. CH2Cl, if you see, means primary. CHCl, if you see, means secondary. CCl means what? Tertiary. Just remember like that. This is called what? Primary. CH2Cl, yeah. Okay. Don't be confused. CH2 primary. This is what? CHCl. So what? Secondary. Tertiary. Here also I replace H by CH3. Understood? CH2 double bond CH, C, CH3, CH3, Cl. This is called what? Tertiary. Right fast. That's all. Understood? Halogens attached to sp3 carbon, which is attached to carbon-carbon double bond. That is called what? Allyl halides. Understood? Understood? One more examples I'll give this in this category. In this means allylic. Okay, what is this? Tell me. They asked the structure they asked already. Halogen attached to this carbon, no. But here who is there? One carbon is there. One hydrogen is also there. Okay. So what? How many? How many? How many? 4 bond? No. 4 bond means called what? sp3 carbon, which is attached to what? Carbon carbon double bond. No. Halogens attached to sp3 carbon, which is attached to carbon carbon double bond. That's what it's called. This also belongs to what? Which category? Allyl halides. Understood? Okay. If I put double bond here means that belongs to that category. Okay. So understood. So this type of structure also. So you see that halogen, which carbon halogen is attached. Okay. Then you can able to guess which kind of halide that is. Okay. Right. This also very important one. Note down. Here they won't give hydrogen, but you must know hydrogen is there. Understood? Okay. This is also an example, very good example. Okay. Are you following? Okay. Any doubt means ask me. Okay. Another one. A, B is sp3. We have seen only two, no? Allyl halides, sorry, alkyl halides and allyl halides. One more thing, note down. Benzylic halide. Benzylic. Third one is, see, benzylic. Benzylic halide. Okay? Okay. Right one, small definition. Halogens attached to sp3 carbon. As usual definition. Halogens attached to sp3 carbon, which is attached to benzene ring. Okay, which is attached to benzene ring. Correct or not? Okay, that's why it's called benzylic halides. Okay, so here is then halogens attached to sp3 carbon, no? Correct? sp3 carbon. 4 bonds should be there. This carbon. Okay. Then only it's called sp3 carbon, which is attached to what? What I told? Benzene. Correct or not? Okay. So here both the side HH means what? Primary benzylic halides. This is what? If I put CH3 means here H is there, it's called what? Secondary benzylic halides. Here also CH3, here also CH3. So what? It may be anything, methyl, ethyl, like that. Okay. Anyhow, CCl is there. No, I told you there. Okay. This is called what? CH2Cl. Correct or not? CH2Cl. This is what? CHCl, secondary. This is called what? CCl, tertiary. Understood? Right. Okay, just remember like this is a very short way to identify primary, secondary, tertiary. Okay. Keep on pencil. Okay, so don't use always the pen. Okay. If I teach organic chemistry, not only organic chemistry, but especially organic chemistry, you must use pencil also. Okay. So these are all differentiated means you can easily understand. Okay. Then that's all. These are all 3 category over. Then come to what? sp2 carbon. Under sp2 hybridization. Okay. Under this we have now 2 types. What are the 2 types means? sp2 we have first one is vinylic halide. Vinylic halide. Vinylic halide. That I already told you, it will be like this. Cut or not? Okay. Here, how many sigma bond? How many sigma bond? We have 3 sigma bond. 3 sigma bond means it's called what? sp2. Okay, just only remember. Now write small definition. Halogens attached to halogens attached to sp2 carbon, sp2 carbon of carbon double bond. You put like that. Halogens attached to sp2 carbon of, immediately the double bond will come. Understood? Last time that is attached to, again one more carbon will come. Okay, immediately here double bond will come. So halogens attached to sp2 carbon of carbon double bond. Understood? Okay. So here best example means, I'll put same thing here, CH. Can I do like this? Okay. CH2 double bond CHCl, the best example. Or here we don't have any primary, secondary, tertiary in this case. We cannot able to predict secondary, primary. Okay, here only the name only. This is called vinyl halide. That's all. Okay. Then last time I told you I put double bond here. No, I put double bond here. If I put double bond here means what? Allylic halides. If I put double bond here means called what? Here you know that. Can you able to differentiate? Here one sigma bond, here one sigma bond, here one sigma bond. So 3 sigma bond only. Okay, that's why it's called. It comes under this category. Okay, right. This is the example. Vicinal, vinyl, totally different. Yeah, vicinal, we study, no, vicinal. That is 2 halogens. It's called vinyl, this is. Okay. Then B, aryl halide. Aryl halide. Aryl halide. Right, one definition. Halogens attached to sp2 carbon. Halogens attached to sp2 carbon of benzene ring. sp2 carbon of, immediately benzene will come. Okay. Okay. Halogens attached to sp2 carbon of benzene ring. That's all. So here you know that best example. This is only one example. Benzene no, here benzene no. So this is what? This carbon is called what? This carbon, the chlorine is attached to this carbon only. No, this carbon is called what? sp2 carbon. Understood? Are you following? So here one sigma bond, here one sigma bond, here one sigma bond. This will be pi bond. Understood? So 3 sigma bond. That's why. Understood? Okay. So chlorobenzene is an example for aryl halides. Understood? Okay. Right. That's all classification. Okay. Over. Based on hybridization, they'll give one structure which kind of halide that is. Okay. Okay. Now we are going to study about the preparation. Okay. This is all introduction. We didn't enter the topic. Now only we are going to study about the preparations. Okay, preparations of haloalkane as well as chemical properties of haloalkane. Okay. Okay. So first we put the heading preparation. Okay, preparations of haloalkane. Okay, see. So most important means here, see, listen, very important one. Free radical halogenation method. Free radical halogenation. See, here each and every, I already told you the name reaction is very, very important. Then some reagent, each and every reagents we have some role will be there. Okay, that the role, the function of the reagent, if you know, means you can use to find the product. This is the product. Okay, so that is important. Then some trend also very important. Trend. Okay, so boiling point trend, basic character trend, this and all. So each and every chapter we have, this also we have to go through. Okay, so we can use to guess the product. Okay, we can use to get the answer. Okay, suppose if you see means here 4 options means 2 options we have to, first of all you should neglect. Now we are among the 2 options only we have to select which one is the correct one. Okay, So if you practice all this equation and all means you can easy to answer. Okay, right. Okay, first one, what's our aim? To prepare haloalkane. Okay, right. It may be chloromethane, chloropropane, anything. Okay, or 2-chloropropane. So haloalkane is aliphatic compound. See, uh, what is free radical? Free radical means what? Suppose chlorine Cl2 is there. Cl2 means I'll write it like this. Cl single bond Cl. When you apply some light energy, the bond will break. Okay. So actually, how the bond is formed, the mutual sharing of electron between the two atoms, the bond is formed. So it's called covalent bond. Whenever if you apply light energy, the bond will break. Each atom retain its electron. So Cl dot, it gets electron. This chlorine gets its electron. This chlorine gets its electron. So Cl dot we should write. Any odd number of electron on the species is called what? Free radical. This is called chlorine free radical. Understood? Suppose CH3. Tell me. This bond will break. So CH3 dot 2 times. Any dot is called, you can say, free radical. Okay, the free radical is obtained by bond breaks due to light energy. Bond break due to light energy. Understood? So we put dot. It's a methyl free radical. This is called chlorine free radical. Understood? Okay. So mostly the bond is broken between two similar elements. Mostly here CC, the bond breaks between C and C. Here bond breaks between Cl and Cl. Okay. So that time only we are getting what? Free radical. Understood? Okay. You know that? Say here simply the questions. What's the question means? See, I'll give this one. Say CH3, CH2. What is this? Just remember, any halogens, not chlorine, bromine, anything. Okay, mostly chlorine, bromine only they'll use. H nu, if you see, means what's the role of this? Means replace sp3 hydrogen by what? Halogen. Just only remember. Replace sp3 hydrogen by halogen. What's the meaning for this? You expand this. All are which carbon? sp3 carbon or sp2 carbon? Is there any sp2 carbon? If you expand all this, all the carbon around we have 4 sigma bond. So all are sp3 carbon, isn't it? In this sp3 carbon hydrogen is attached, no. That's what's called sp3 hydrogen. Okay. So here I told you here, now replace one hydrogen by halogen. That's all. Simply remember. You replace one hydrogen by halogen. If you replace here, primary. This hydrogen replacement primary. This also what? Primary, no? First and last. Middle? This also secondary, this also? Secondary, no. Because these carbons are attached to 2 carbon. That's what's called secondary. This carbon attached to 2 carbon, no. That's what's called secondary. Understood? Okay. We are going to, we have chance to get 2 kinds of product. One is primary alkyl halides and another one is what? Secondary alkyl halides. These are the possible. Okay. So first one, I'll write it here. CH3, CH2, anything, any one we can replace. This hydrogen or this hydrogen, both are primary. Understood? Cut or not? Plus, I put here CH3, CH2, CH, Cl. Understood? Okay. 1-chloro-butane. This is called what? 2-chloro-butane. Okay. So here, sometimes both are. We are getting both the products. Sometimes they'll ask only the stable product. They'll ask. Stable product means what? Just remember, tertiary is more stable than. Just remember. Okay. So this is called primary. No. This is called secondary. No. So this is what? Stable product. Right. Right. Fast. Okay. Very important. This is very, very important. You must know what is the role of Cl2 in presence of light energy. Okay. If you answer this, you understood everything. Okay. What's the product? Tell me. What's the role of this? Replace sp3 hydrogen. Who is sp3 hydrogen here? This hydrogen or the hydrogen which is present in benzene ring, which is sp3 hydrogen. This is sp3 hydrogen. Correct or not? Okay. Because this is called sp3 carbon. No. You expand this, we get 4 sigma bond. But here, just remember, this the hydrogen which is present in benzene ring is called what? sp2. This is called what? sp3. So this only we can replace. Understood? In presence of sunlight, we get the product like this. Okay. See. Then what's the product? Tell me. Replace. Are you following? Same thing. Once again. I write it here. Same thing here. This is presence of sunlight. This is what? Same chlorine is added. This is called what? Dark. Now tell me, what's the answer? Dark. Dark means absence of sunlight. Absence of sunlight means we can replace this hydrogen, any one hydrogen. But not any one hydrogen. This is what compound this is? What compound this is? Toluene. Toluene is an ortho and para directing group. So we have we have hydrogen. Have you written this? I finished all this? Yes, sir. Okay. Okay. See, I'll write it here. Make everyone understand. See, what's the product? In absence of sunlight, you should not touch this one. Here we can put chlorine here. One possible product. Another possible product is what? Orthochlorotoluene. This is called what? Parachlorotoluene. So among this, who is the stable product means? This is a stable product. Okay, just copy them. So same toluene reacts with sunlight, reacts with chlorine. In presence of sunlight, it gives this product. In absence of sunlight, it gives this product. Okay. Okay. Presence of sunlight only I put this and all. Okay. Replace sp3 hydrogen. Absence of sunlight, replace sp2 hydrogen. Okay. Just write this only, write correctly. Very important. Following. Are you written correctly? If you go this way, we get this product. Or if you go this way, we get this product. Okay? Understood? Right. It's very important, this one. Suppose you tell me.
Sir, if you ask why para is major product.
Para is?
Major product. When we get those.
No steric effect. No, suppose here here suppose here CS3 is there, no? Okay. So here, due to steric effect, two groups are near, no? Due to steric effect, this is somewhat minor product. Here, if it attacks means what? No other group nearby. So here, due to no steric effect, para is the major product, always. Understood? All the cases, para is the major product. Okay. But here, two groups are nearer one group, no? So, difficult to attack this position. That's the point. Okay. Okay. Now tell me this one. This one example is given for one Tell me, what's the product? Major product or stable product?
CH2, CH2, Cl.
CH2, CH2, Cl. If you replace this hydrogen means primary, no? If you replace this hydrogen means primary. I am asking which one is the major, which one is the stable product. I want stable product means
That's to CH2.
this hydrogen you have to replace. Okay, so what? But you write both, but write cut or not. Okay, you write both and write the stable product. CH2, Cl. This is called what? Stable product. Right, fast. This also given in a textbook. Tell me. For one reactions, I can teach for 20 minutes. For one matra preparation, it will take 10 minutes. We have so many examples are there. Okay, but here we don't have more time. So understand the concept. Okay, what's the role of this one? Okay, now tell me. What's the product? See, this carbon is called, these two carbon is called what? This two carbon is called what? sp2 carbon. Double bond is there? No. Okay, this is called what? sp2. This also what? sp2. So then these four is called what? This one is called what? sp3. Now we can replace any, here only we can replace. So what's a product means? You can replace any one place. Okay. Cut or not? It's a product. Okay. Right. It's also important. Textbook is given. Finished? Okay. Can you able to differentiate sp2 and sp3 carbon? Okay, right. So next one, another method. From alkene, put the heading, from alkene. From alkene, second method is, from alkene. Okay, alkene means, you take, listen, you studied the Marconic rule and anti-Marconic rule, no? Studied or not? Marconic rule, anti-Marconic rule. What is Marconic rule? Marconic rule. So here, plus minus, no? Okay, here, wherever double bond is present, we have to split. Cut or not? Okay. What is the Marconic rule means what? Negative part goes to carbon atom. Negative part goes to carbon, which carries what? Which carries less number of hydrogen. Understood? Negative part goes to carbon, which carries less number of hydrogen. Negative part means, who is negative part here? This is negative part, isn't it? Here we are splitting, no. Which carbon having less number of hydrogen? Which carbon having? This carbon having, no, less number of hydrogen, no. So negative part goes here, the negative part goes here, understood? The positive part goes here. Understood? So what's the product? CH3, CH3, CH, Br, single bond, no. Whenever anything coming, it becomes what? Double bond becomes what? Single bond. Understood? Okay. 2 bromo, propane. Okay. The same thing, this is considered A. CH3, CH, double bond CH2, see HBr, listen, peroxide. If you put any peroxide, okay, same thing, everything same, but we are adding one catalyst. If you have peroxide means, we should follow what rule? What rule? Anti-Marconic rule. Understood? Same thing here, negative part, instead of negative part, we put what? Positive part goes to carbon atom which carries less number of hydrogen. Are you following? Okay. Positive part means what? Which is positive part here? First of all, plus minus. We have to split here. Understood? Positive part means a positive part, no. Positive part goes to carbon atom which carries less number of hydrogen. So positive part comes this side. Negative part goes here. Okay, now product is what? CH3, CH2, CH2, Br. Are you following? This is called 2-bromopropane. This is called what? 1-bromopropane. Right fast. Understood? Very important. Understand the concept. If I teach concept only, it will take more time. If I want to give more examples, it will take twice the time. So I'll teach all the concept. Okay. Side by side, you have to go through all this. So many questions are there in your textbook. In-text question, exercise question, example question. Okay. Then so many questions in your guide also. Just go through. Small difference, just okay. Negative part, this is called positive part. Okay, understood, right? This is called anti-Markov rule. If you see the peroxide and the arrow mark, so we have to follow anti-Markov rule. Okay, this otherwise is called Karash effect. Karash effect. Okay, or peroxide effect. Okay, Karash, K-H-A-R-A-S-H. Okay, right. This knowledge is not given in a textbook, but just remember. Okay, from alkene also we can get what? From alkene also we can get, haloalkane. Understood? Okay, it is haloalkane, no? These are all haloalkane, no? Okay, right. So one method. In-text question is also there. You have exercise questions, okay, based on peroxide and normal Marconic rule. Okay, just go through. Okay, then third method is this is simple one, halogen exchange method. Halogen exchange method, right fast. Halogen exchange method. So here under this we have two name reactions. What is the name reaction studied or not? Finkelstein reaction. Schwarz reaction. Okay, Schwarz reaction. Okay, halogen exchange. We prepared halogen compounds. Now we are going to exchange. Suppose if you have chloroethane, already chloroethane is there. I want to get bromoethane. So then only we can use what? Sodium bromide. You know that. What happened? What happened? The two halogens are exchanged, That's what's called halogen exchange reaction. Okay. So what's the product? CH3? CH3, CH2, Br, correct or not? Plus NaCl. Okay. Sometimes again it will come back. There's a chance to come back. No. Again halogen exchange takes place. Then only we use what? Acetone. Acetone is a solvent. This NaCl dissolved in the solvent means no chance to come back. The reaction will not come back. Again it will form this one. Okay.
You have to mention triacetone.
Triacetone, I guess. Triacetone also we can use. Okay. What's the principle behind? Why we are using triacetone means to avoid backward reaction. Okay. That's a purpose we are adding. No. What's the principle behind? Le Chatelier's principle, isn't it? This is a principle, no? Suppose if you want to proceed reaction forward or backward, if we change the conditions, okay, so we can proceed in any directions. That principle is called what? Le-Chatelier's principle. Okay. If you are not adding this one, it will come back. If you are adding this one, it will proceed only in forward direction. So if we can make the reaction in any directions, we can proceed the reaction in any direction. The rule is called what? Le-Chatelier's principle. You studied in 11th standard. Okay. Okay, right. Then next one here, Swartz. This also same thing. But mostly fluorine compounds we can prepare. Fluorine. Okay. So just remember AgF. Here left hand side we can put anything. Okay. So the product will be, what's the product? Fluorine compounds we can prepare. Always fluorine compounds. So plus what? Ag? AgI. Same thing. This also we have dry acetone now. Okay. Swartz reaction. Next. Understood? Okay. The next one. From alcohol. Fourth one is from alcohol. From alcohol. This is a simple one. Here, the best method only, just remember. After that, don't worry about the other one. You take ethanol. Okay. HCl we can add, or PCl5 we can add, or SOCl2 we can add. Okay. Or all are getting what? What happened? Which will be removed, you know that. Product will be what? Chloroethane. Understood? Ethanol plus HCl, we get H2 will be removed. The product will be what? Chloroethane. Cut off. All the compounds are replacing OH group by halogen. All the compounds. But this is the what? Best method, they are saying. Okay, thionyl chloride is the best method. Sir, I will write all these first of all. Copy them. All the reagents are replace what? Replace OH group by, halogen. No, CH3, CH2, Cl. This is not you right. PCl5 only you can use to split, no? Cl, you studied. Correct or not? CH3, CH2, Cl plus POCl3. Correct or not? POCl3 plus HCl. Understood? Okay. This one, you tell me. CH3, CH2, OH. Cl, SO. So CH3, CH2, Cl plus SO2 plus HCl. Understood? Okay. So here, why I am saying this is the best method means CH3, CH2, Cl plus SO2 plus HCl. Okay. Because all are volatile. Our aim is to get only haloalkane. This will be volatile means what? What happened? So now we have only this product. No. Suppose this is volatile. This is not volatile. No. This is liquid state. Both together in the vessel. Both together in the container. Now we have to separate these two. No. Okay. It will take some time. We have to follow another process. But here not like that. Other products are easily escaped as a volatile compounds. Now we have only the main product. Then only I am saying what? This is the best method. Okay, thionyl chloride. Just remember, the name is called thionyl chloride. Thionyl. Okay, right. Understood? Are you following? Okay. So here, the trend also, just remember, trend. Here, what's the trend means? Here, I am taking only primary alcohol. But which alcohol are reacting More means tertiary. This only just remember. Who is reacting with halide compounds very fast means tertiary. Then in HCl I am taking, okay. Who is reacting very fast means HI. This two trend, just remember. Okay. HF. You following? This is large size iodine. Okay. This is more stable cation. Okay. Tertiary carbocation is more stable. Okay. So here easy to break. It forms carbocation very easily when compared to other. Okay. So this the true trend, just keep in mind. Okay, understood? Okay. Are you following? I plan to complete both. But very difficult to complete. At least one. Sure. Papa. Finished, huh? Okay. Chemical properties, one or two properties I'll finish. See, chemical properties, put that in. Chemical properties of haloalkane. Okay. Simple one. Here, first one, you studied already. Wood's reaction. What is Wood's reaction? Can you remember? Try ether, very good. 2 carbon becomes 4 carbon. Because of what? Dry ether. It's a solvent. This is, halogen compound, haloalkane having, if haloalkane having 2 carbon means, it becomes what? Alkane. Alkane having 4 carbon. This is the point. Okay. You take 2 haloalkane, in presence of, what's the metal? Sodium is a metal. Understood? If you see sodium, you must remember this is called what? Wood's reaction. Understood? Otherwise, you cannot judge what's the product. You cannot be able to guess. Understood? Sodium is a one reagent, one temperature, pressure, some reagent. This only we can, if you see the reagent, same reagents many times, not only one time. Okay. Many times you come across this kind of reaction, you can easily guess. This is a product, we can easily guess. Okay. Suppose any questions, if you attend in physical chemistry, it will take we have to work out and find out. Okay. It will take more time, not more time, but the answer will be simple. But if we are understanding the concept in different way, means it will take more time. Okay. So, but when compared to this, the organic chemistry, very simple one, just like biology. Okay. Biology, you are all studying biology only, we are giving more importance, okay. To become a doctor, we are all studying biology. Okay. At the same time, concentrate chemistry as well as physics also. Okay. Okay. Then only you can cross 600. If you want to, nowadays 600 is very easy one. Everyone is getting. Mostly repeaters are getting. You are all repeaters. So you must get more than 600. Okay. So concentrate all the subject. Only, biology only, not chemistry only, not physics only. Concentrate all the subject. Understood? Okay. Okay. So now what's the example? You can take any CH3CH2Cl. Okay. The question will be like this. Okay. So very easy questions. Only the students are thinking like this. NaCl is removed. Remaining CH2CH2, CH3CH2. CH3CH2 means it's not a product. Okay. So it's a radical only. So if you see sodium means you should write 2 times. They will give this part only. Okay. But you should write 2 times of this and 2 times of this. Okay. So in process of that dry ether is a solvent. Understood? Okay. What's the product? They will give only 1 time, but you write 2 times. Then only you can get. Okay. Tell me. NaCl here also. NaCl. This CH3, CH2, CH2, CH3. we get alkane, no? I told you, no? Alkane, understood? Okay, so product CH3, CH2, CH2, CH3. This is called what? It will be twice always. If you take butyl chloride, it will be octane. Okay, mostly even number only we should take. Not suppose one is exception case. Methyl chloride if you take means we can get ethane. Ethyl chloride if you take means butane. Don't take propyl chloride. If you take propyl chloride means it will be, we are getting mixtures of alkane, mixtures. Sometimes isomers also will be getting. So again we have to separate. That's very difficult process. Mostly even number only we are taking. 2 means 4. 4 means 8, like that. Okay, right. Just copy them this one. This is a concept, okay? Keep in mind this one. Understood? Okay. Now, you do yourself later. You do yourself later. You put sodium, question mark. You put 2 chloro. Leave some space. Okay. Leave some space later. Understood? Second one. Beta elimination reaction. Beta elimination reaction. Clear? Are you following? If you see sodium means called Woods reaction, just remember, okay? Right. Beta elimination means other name is called dehydrohalogenation, right? Right. Dehydrohalogenation. Okay. See, just write from alpha carbon, just write the point, important point. From alpha carbon, halogen is removed. Halogen is removed. And from beta carbon, from alpha carbon, halogen is removed. From beta carbon, hydrogen is removed. Okay. To form an alkene. To form an alkene using alcoholic KOH. That is very important. From alpha carbon, halogen is removed. From beta carbon, hydrogen is removed to form an alkene using alcoholic KOH. Alcoholic KOH very important. Okay, if you put aqueous KOH, we are not getting this product. We are not getting alkene. Okay, that's the concept. Okay, see one example I'll give. That is here, best example, simple example. Alcoholic KOH, remember, sodium I told you, Woods reaction. Alcoholic KOH means always we are getting this called DR.D.RAJASEKAR.M.B.B.S, beta elimination. We must get only alkene. Okay, alcoholic KOH. Which is alpha carbon? Which is alpha carbon? The halogens which are nearer to this alpha carbon, no? This is called what? It goes on. Alpha, beta, gamma. Okay, okay. From alpha carbon? From alpha carbon? Halogen is removed. Halogen is removed. Okay. Okay. From alpha carbon, halogen is removed. Yeah. Okay. Solunga. How halogen is removed? How halogen minus KCl, no? This is a way to remove. Okay. From beta carbon, hydrogen is removed. How hydrogen is removed? One hydrogen. Okay, this is one hydrogen, one OH. What is that? Just remember. Okay. Minus H2O. So what? What's the product? Now CH2 only, no? CH2. See, between alpha and beta only the reagents are removed, no? Okay. Then between alpha and beta only we put what? Double bond to form an alkene. See, to form an alkene. Understood? It's called. Okay, write fast. You write yourself. Be quick. Alcoholic AOH. Write fast. What's the product? Tell me. CH3, CH, double bond, CH2. Very good. Okay. What's the name of the product? What's the name? Propene, no? Cut or not? CH3, CH, double bond, CH2. Understood? Propene. Okay. Right. Okay. So this now you try yourself. Then one more thing, this is only complete. See, here, which is alpha? Now tell me, which is alpha carbon? No, it's very important. This is alpha, no? Alpha. This is beta. This also beta. Nearer, no? This also beta. Which beta we can take means? Which is longer side? It's a long. Here two carbon, no? Just remember like this. Two carbon, here one carbon, no? This beta only we should take. Okay? Tell me. What? So here, KCl is removed. This beta product will be CH3, CH, double bond, CH, cut or not? Understood? Okay, it's very important. This only, the principle is called Sets-Up rule. Sets-Up. Okay, sometimes here Z or Z, Sets-Up rule. Okay. See, this beta also we can take. But if you take this beta hydrogen, then only we are getting stable alkene. Stable alkene. Okay. If you take this beta hydrogen, we are taking unstable alkene. Okay. Then only stable. We want to get only stable product. No? Then only that rule is called Sets-Up rule. Okay.
So they ask reasoning questions like why only alcoholic is not aqueous?
Why only?
Alcoholic, not aqueous.
Aqueous means, that will undergo nucleophilic substitution reaction. That will undergo only nucleophilic substitution reactions. Then only alcoholic AOH we are taking. Alcoholic AOH only, nucleophilic means what? You just replace Cl by OH. Okay. Then only we are using alcohol as a solvent. So if you use alcohol, then only we are getting that alkene compounds. Okay. Or small changes in the concentration, reagent, temperature, pressure, the product will be different always. Okay. Or we can say, solvent only changes. That's aqueous means water is a solvent, no? Here what? Who is the solvent here? Alcohol is a solvent. But solvent change, any small changes in, factors, the product also will be changing. Okay. Are you following this one? Okay. So based upon here we have some in-text problem is also there. Okay, we try. Okay. Okay, students, I'll stop up to this. Okay, I'll continue in the next class, remaining part. Okay. Any doubt up to this?